Good morning, everybody. Thank you all very much for tuning in today for this demo cast with Salt Security. My name is Sunil Dutt, and I'm also joined here with my colleague Gray McMillan, who will later on show you a demo as well. But let's start with the topic of today, API security, and particularly the why of API security, because it is no longer software that is consuming all of our resources nowadays, right? Whether you know it or don't know it, and probably all of you do, we are nowadays literally saturated with APIs in our infrastructure. And there's no surprise there, right? Because particularly due to all the innovation that a lot of our customers are going through, all that digitalization and the digital transformation journey, we see a massive adoption of cloud technologies, microservices being implemented, and particularly all that innovation truly happens when you allow all those components to exchange information with each other. And that's why the API has become the most important catalyst in our infrastructure for all that digitalization that we have been going through. So, which is a great thing. But unfortunately, there's also been a downside to it because if you look at what the true purpose is of an API without getting too technical about it, it is to expose data. That's basically what it does. And we have all learned nowadays that everywhere where data is being exposed, you would have some bad actors that are trying to get their hands on that data for their own personal benefit. And that's unfortunately what we've seen happening across Europe as well. Big logos that are spending a lot of time, money, resources, technology to keep their logos out of the front pages actually still made the news. And interestingly enough, if you nowadays look at the anatomy of the breach, you will see that often enough it is caused due to a leaky API. And this is not completely hitting us by surprise. We were actually already warned for this phenomena back in 2017 when one of the bigger analysts, Gartner, actually made a very bold prediction. And that was that from 2022 onwards, the APIs would become the most frequently abused attack vector moving forward. So let that one sink in for a moment, because if we just rewind and go back to 2017, I think most of us were preoccupied with securing endpoints and securing emails. Nobody was really thinking about APIs. But more interestingly enough, Gartner actually released a new quote, and this was at the end of 2021. And Gartner was able to statistically prove and verify that this was already set in motion. And what was happening, according to Gartner, the way that they explained it, was that hackers were no longer primarily focusing their attention on attacking users through endpoints and through emails. They were actually shifting their attention towards attacking developers as well. So the question is why? Why all of a sudden do we see these attacks towards the development part? Well, first of all, the endpoint that we're all using nowadays is better protected with great software. And most users are also getting some security awareness training, telling them what links to click on, what not to click on. Well, that's what we hope at least. But there has been a fundamental change in the world of APIs from an attack surface perspective. Let me just explain to you what I mean with that. Because if you look at the world before all that digitalization, customers would be interacting with few APIs, but more importantly, these APIs rarely had access to sensitive data. But if you fast forward to today, you will see that customers are using and deploying and interacting with tens, hundreds, maybe even thousands of APIs. And more importantly, these APIs nowadays are accessing PII data or personal identifiable information. So you can see that the attack surface all of a sudden is growing exponentially, combined with accessing sensitive data. That all of a sudden makes this a very, very interesting attack surface to focus their attention on from a hacker's perspective. And that's exactly what we've seen, because this actually resulted in the fact that the sophistication of the attacks completely changed. So if you look at the world previously again, when the APIs were actually not an interesting attack surface, we would see very simple attacks. It's what we call the one and done attack. What we typically saw was that a hacker would try to hide malware in a piece of traffic. This would be, in this case, an API call, something like an SQL injection, for instance. And most customers would have technologies in place like a web application firewall, or maybe even an API gateway that could do deep packet inspection and actually detect the malware and block traffic so the customers would be safe. So nothing too sophisticated and nothing too complicated to actually catch and remediate. But what we're seeing today is something completely new, something that we haven't seen before as an industry. Because what we're seeing now is what we call a low and slow attack. This is no longer an attack that is predominantly depending on malware. What this attack actually does is it manipulates the business logic of an API to have it do something that it probably shouldn't be doing, which is often in most of the cases, exfiltrating data. So what a low and slow attack actually looks like is that a hacker is actually coming into your API, pre-authenticated, by the way, because nowadays you can just buy authentication credentials on Telegram channels and on the dark web. So they come in authenticated and they sit around in what we call a reconnaissance phase, where they take their time to fully identify the business logic of your API. And once they have understood the business logic of the API, they mimic or they actually launch a sequence of API calls that mimics authentic traffic. And because these look so authentic, your existing technologies like a WAF or an API gateway is not capable of distinguishing it from malicious traffic and just lets it pass through. And this is what we typically call a business logic based attack. It's spread out over a longer period of time, which can be days, weeks. We've seen examples of months and even a couple of examples of more than a year. And it's a sequence of API calls. So because this is a complete new approach, you need to have a new way of thinking on how to protect yourself against these very advanced attacks. And this is where Salt comes into play. So what we can do for customers is help customers with three key challenges. The first challenge is to have full visibility in your API estate, because if I would ask any of you, do you actually know how many APIs you have running in your environment and with how many APIs you are actually interacting on a daily basis? And that is a fundamental question to ask, because what you cannot see, you cannot protect. And this actually applies to any cybersecurity strategy. But the challenge, though, is that most of the customers that we talk to actually don't have this visibility. And again, what you cannot see, you cannot protect. So if you don't know what your estate looks like, how would you actually know if you're maybe overexposing sensitive data already today? And this is where Salt can actually help our customers, because what we actually do, fully automated and continuous, we do a discovery and cataloging of all your APIs, in-house developed APIs, third-party APIs, shadow and zombie APIs. Maybe those are quite important because those are the APIs that haven't been patched and updated and are basically a door wide open at the back for any hacker to come in. And once we have mapped out all those APIs, we can also immediately detect if any of those APIs is already overexposing sensitive data. The second part, what we can help with, is what we call runtime protection. And this is really the most important part. And let me explain to you why. What we mean with runtime protection is protecting the APIs that you have running in production today, right now. So why is that the most important? Well, simply, if I would be a hacker, then I would be sniffing your environment for something that I could actually connect to, right? And those are the APIs that you have running in production. But again, if I would ask you a question that if anyone would be hacking or manipulating one of your APIs right now while you're watching this webcast, what kind of techniques or technologies would actually make you aware of that fact? And particularly if you're looking at the most advanced and the most common threats that are nowadays also documented in the OWASP API top 10. Again, that becomes very complicated because either you probably believe that your existing technology stack, like the WAF or the API gateway, would take care of that. But what we've learned today is that these new types of attacks, these business logic based attacks, these technologies like the WAF or the gateway are simply not purposely built to be able to detect these kind of attacks. Because we've learned that these attacks are spread out over a longer period of time and are actually mimicking authentic traffic. So to be able to catch these types of attacks, you first need to understand what normal API traffic should look like based on your specific business logic across all your APIs, all the subsequent clients, and all the users that you have. And to understand what normal looks like, you need to create a baseline. Baselining means that you need to analyze a ton of traffic before you can actually determine what normal looks like. And what we don't want to do is install 20 or 30 servers in the data center of our customers to do all that number crunching on-prem because, well, it's not scalable and it's also not good for TCO. So what we've done at Salt is we've built a cloud scale big data architecture at the back end that runs all the analytics for you real time and provides actionable data. And a big plus of doing it in this way is that we actually become aware of the context of all the findings in your API traffic. And this is absolutely the key to catching business logic based attacks, because again, spread out over a longer period of time and very subtle manipulations, you need to have context awareness. We are no longer depending on techniques like deep packet inspection. We actually understand that you shouldn't be looking at one individual picture. You should be taking a lot of pictures and putting them all together and turning it into a movie, because then the sequence of actions will tell you that something fishy is actually going on. So let me give you an example of that. How does that relate to current techniques and technologies that customers might be working with? Because if you need to scout through an ocean, a sea of API calls, and you need to analyze millions, maybe even billions of calls with very, very subtle manipulations, it becomes impossible for a web application firewall to do this work for you, because it has been purposely built to look at individual packets and determine if any malware might be hidden in there, or to apply certain rule sets. So nowadays we see some evolution in the WAF, and we see what we call the WAP, right? It's, well, you could call it the WAF on steroids. It has a bit of a broader view, but still it cannot have enough context and scan for enough context to determine if the correlation is actually telling you that this is a malicious activity, or maybe this is just an honest mistake from a user. So the only way to be able to detect these business logic based attacks that are so spread out is to apply a wide angle lens. You need to have full context of all the events that you're seeing in your traffic. And the only way to be able to analyze so much traffic in a way that's also effective is by having a cloud scale big data architecture at the back end, but also having very mature algorithms and machine learning and AI engines that have also been tested by time. And it's, by the way, not only us that are saying this, right? If you would look it up, any analyst, Gartner, Forrester, IDC, OWASP, are all very vocal nowadays about the fact that customers really they really have to innovate in their technology stack, because their current defenses are simply ineffective and are not offering sufficient protection against these very advanced business logic-based attacks. Which brings me to the third part. It's what we call the proactive security. It's more commonly known in the market as shift left. And what I mean with that is, let's look at all the APIs that you yet have to put into production, right? So the pre-production APIs. And let's expose those APIs to all the crazy things that we've seen in the wild, including the OWASP API top 10. So basically pen testing them with everything that we've learned from all the attackers that we've seen. Also applying pre-production design analysis and sharing this as a report to your development teams on where they need to harden the API before putting it into production, so you're actually safe from day one. So how do we do it? I just want to talk to you a little bit about the architecture before I pass it over to Graham. So Salt Security by choice is not an inline technology. What we actually do is we make a mirror of all your API traffic by capturing this from various endpoints in your infrastructure. Preferably, we would take one of the choke points, like a load balancer or an API gateway, but we can also make a mirror from microservices, Kubernetes containers, firewalls, WAFs, wherever the API traffic passes. So once we've collected that API traffic, we run it through our AI-powered big data engine. This is where we start to identify all the APIs that are occurring in your traffic: external facing, in-house developed, third party, shadow APIs, zombie APIs. We map them all out. Typically, this process takes a couple of hours. And this is really the power of big data running in the back end. It doesn't cost you days or weeks. The time to value is very short. Once we've mapped out all these APIs, we then go to the second phase. And this is where we run the traffic through our context engine. This is where all the machine learning also kicks in, because this is the phase where we start determining what normal API traffic should look like based on the business logic and based on all the clients and subsequent users as well. So this is where we analyze a ton of traffic to make sure that we understand what your business logic looks like. And again, this process typically takes hours. So most of the time you will have a same day result that we can immediately offer protection. So once we've discovered all those APIs, we also immediately see if any of those APIs is overexposing sensitive data. And once we have determined that, we can also detect and block any attackers in their tracks as well. And interestingly, anything that we learn from an attacker, we can also turn it around and use that as a proactive pen test, applying the shift left methodology and increasing and improving your overall security posture. So what does that look like from a deployment scenario? So like I mentioned, we're not inline, we're fully automated and continuous. And that is pretty important actually, because your APIs nowadays are participating to your overall IT lifecycle management. They're getting patched, they're getting updated. So they're basically frequently changing. So we capture all those changes as well. And we're also working in an environment agnostic way. So we can interpret any type of API traffic, regardless of the client that's generating it, and in any type of API programming language. The API collection options that we have are all benefiting from native integrations. This is really important because it's a native integration, you don't require any coding or agents. We can capture the traffic without causing any latencies as well. And you see a couple of logos here on your screen for the most popular ones that we're working with today, but we have more than 60 integrations out of the box. So once we have a copy or a mirror of your API traffic, you actually have two options. The first option is to route all the API traffic to our SaaS solution, where we already strip out all sensitive data and we can immediately provide protection to you. Oh, and I need to plug in my laptop, I see. Obviously, here in Europe, this is not a popular option because we do have some customers that might have concerns with GDPR and transfer of sensitive data. So for those specific customers, we have developed what we call the Salt Hybrid Server. The Salt Hybrid Server is basically a stateless VM or a Kubernetes container or a virtual appliance that you can deploy in your own environment, meaning it can be deployed on-prem, but also in your own cloud. And what the Salt Hybrid Server actually does, it translates all the API traffic to what we call API metadata, stripping it all from sensitive data and sensitive information, and making sure that you can use the solution in a fully compliant way. So for instance, if you are, a bank, for instance, if we see a credit card number, we translate the credit card number to 16 stars because we don't actually need to know the credit card number. We just have to know that once in a lifetime, it represented sensitive data. And with that metadata, we can still apply our solution and keep our customers compliant at the same time. So what happens if we detect an anomaly in the API traffic? Well, we then interact with the inline technologies through an API call to trigger a remediation action. This can be 1,001 varieties of actions like blocking traffic, blocking IP addresses, blocking users, but we work with the inline technologies to remediate the attack. What we can also do is fully automate the feedback loop to your development teams by integrating with solutions like PagerDuty or Jira. And we also have customers that love to integrate our threat intelligence with their own SOC or maybe with their own SIEM solution. We can also do that as well. So to tell you and basically to show you exactly how we do all of this, let me now pass it over to Graham and we can take it straight to the demo. And feel free to ask any questions, by the way. As we go, you can just put them in the chat and we'll do our best to answer all of them for you. So thank you very much, Graham. It's up to you.
Great, thanks, Anil. Happy to give a quick walkthrough on the Salt Security dashboard. Now, there's quite a number of features and components baked into this. So, of course, anyone wanting to do a more deep dive of our technology, our features, our integrations, please do feel free to contact us after the session. I've logged into a demo account. I've got role-based access controls in place, multi-factor authentication on the platform as well. And from a quick glance, I can see the number of API and endpoints being monitored, amount of sensitive parameters identified, as well as traffic monitored in the last 30 days. The overview gives a full view. What have we seen in terms of unhandled alerts, monitored APIs? What is our attacker footprint in terms of geographic location? As well as what different attack types have we identified in the last 7 days? It's important to note that Salt Security has full coverage of the OWASP API top 10, as well as utilizing our big data and machine learning. We can spot abnormal responses, abnormal user behavior, and parameter tampering. And that really helps identify an attacker early on in their reconnaissance and probing stage so you can prevent the attack from progressing into data exfiltration or anything worse. Scrolling down, we can see a list of the latest security insights. Where has the SALT platform or technology identified deviations or recommendations around the configuration of the APIs? Where have we identified sensitive data in requests and responses, as well as what have we seen as being your most vulnerable endpoints and the number of critical or severe attacks targeting that particular endpoint. So let's tackle the 3 pillars. The first pillar is around discovery. You can't protect what you cannot see. At Salt Security, we're able to give an organization full visibility over their API, and we break it down into 3 different layers. On the first layer, we have the API host visibility, and we're able to spot those. What are the latest discovery around the API host and their endpoints? What API hosts and endpoints have been attacked? Which of them are resource intensive based on the response size and response count, as well as are your APIs internal or external? We're mapping out those API hosts, identifying the internal and external ones that have sensitive data, amount of endpoints behind it, as well as allowing organizations to attach their own tags to those particular API hosts and API endpoints so that you've got ease of reference further on into the technology. So that's our first layer of visibility. Second layer of visibility around the APIs is actually looking into the API endpoints themselves. Now you'll see that we've got full visibility, whether it's REST, GraphQL, SOAP, XML. We're able to flatten out that entire structure and identify what is the actual technology around it, whether this is an authenticated endpoint, the method behind that particular API endpoint request, as well as the full-on endpoint path. Now, some of the really cool things that we've done with our technology is where we are seeing recurring variables, rather than give each iteration of that endpoint call, we're going to then replace that with a variable. And that means that when you're looking at your endpoint or your API endpoint, you're going to get concise, accurate review and report on all your different endpoints, rather than a mass of each iteration or each variation of that particular endpoint. Let's dive into our third layer of that endpoint visibility. From here, we're able to get full visibility into the parameters, and that's the kind of layer that you're just not able to achieve with a web application firewall. We can see what are the different parameters, how have we identified and defined those parameters. Of course, we're also able to identify sensitive data. Now, that sensitive data has got we've got the pre-built syntax already in our Salt Security platform, but you're welcome to go in and based off your own best practices or your own organization or industry standards, define your own sensitive data. So it's neat to see that that's already in place, but you're welcome to go and supplement that with your own custom input. And again, that sensitive data can be applied per endpoint, per API host, or even across the entire organization. One of the neat things around our API inventory is that it allows you to go in and actually utilize our API inventory to supplement your own documentation. Where you have got your own documentation, great. Let's utilize our IES analysis to bring in that additional documentation and identify where are there potential security gaps or weaknesses in the actual APIs that you are building out. What we're also able to do is define a drift analysis. So where does your API structure or your API documentation vary from what we've actually seen inside your live environment? Where are there shadow endpoints handling sensitive data, as well as where are shadowed parameters defined, and often seeing if parameters are accurately defined or being utilized as per the documentation. Let's take a stab at sensitive data because compliance, GDPR, PCR is one of the key criteria around handling data. With the Salt platform, we're able to identify sensitive data in the request as well as sensitive data in the response. And that, especially, let's say, for example, PCI compliance, gives me full visibility to see which particular API endpoint and whether that endpoint is authenticated when accessing that credit card information. Now, you don't have to go through the whole level of going through the discovery, looking into each particular endpoint and parameter. What we've been able to do is distill and contextualize the output from that actual API discovery. And that discovery is fully agile and dynamic, so that as your APIs are transforming and as developers are releasing new features and capabilities, so we're automatically identifying those capabilities and modifying our learning of those API endpoints and hosts. What we've done in terms of security insights is by tracking those API endpoints, identify where are components that we would recommend better or more controls in place. Like, for example, are we seeing sensitive data in the URL? Or are we seeing sensitive data being accessed without proper authorization? And again, the full ability to quickly dive in and go, where's the API host and that API endpoint that is able to access that sensitive data without having authentication on it. We're also able to identify where are we seeing zombie endpoints or JSON tokens without expiration dates configured. All right, that's the first kind of primary pillar around discovery of the API endpoints. The second pillar is around identifying attackers. And that's one of the key components is that real-time monitoring of your API endpoints and hosts. So we don't want to go in and say these are absolutely every single attack that we've seen against your infrastructure, because we've got APIs that are generating maybe 100,000 API calls per minute. That's going to be a huge amount of noise. What we're able to do with our Salt platform and machine learning is distill that down to what are the attempts, but more accurately, how can we associate or contextualize those attempts back to an actual attacker? And that attacker or classification of an attacker could be based off of a device ID, an IP address, or authorized user profile. Let me show you a bit more information around that. So here we have a full visibility as to this particular attacker, endpoints most targeted, what are the different attack types that he's been running against the organization, what are the server responses that he's been getting by running those particular attacks. We're also able to break into what have been the different sources that he's been utilizing. So we can see that as an attacker, as one would expect, he's been bounced between multiple IP addresses. But what has been quite unique in his attack is his user ID, that he keeps utilizing the same user ID, as well as coming from the same device ID. And we're able to use different criteria to actually identify what is a specific attacker, rather than creating a lot of alerts that would just otherwise swamp security teams. Now, when you're looking at an attacker, contextualization is a key component. We don't just want to identify or flag someone as being an attacker. We want to give a full visibility as to what is that attacker or the traffic or telemetry around that been for the last 30 days. And we're giving it a full timeline. What attacks have we seen? Where have we seen those attacks? Again, with our machine learning, if somebody has utilized 52 distinct values in the last minute, which is 1700% more than normal, that's a kind of behavior that really helps you identify or ascertain whether this is a user inputting the incorrect fields into the incorrect components, or whether this is a legitimate attacker trying to expose gaps in your business logic. Of course, when we are identifying those potential or broken object level authorizations, we're able to highlight what did we see, where did we see that actual attack, even go into further on detail. This is a request that was generated, getting the actual authorization token, analyzing that authorization token and identifying the user ID behind that, and being able to spot that the user ID actually differs from the user ID being utilized in this cookie. And as such, this user has been able to exfiltrate data from another user's profile by actually modifying their cookie, the user ID within inside the actual authentication cookie. And again, that is a massive cause for concern. And being able to identify that and get visibility into that is a key component around SALT technology. Now, at any point in time, you can see that one of those different attacks, where they occurred. As I said, you wanted to get that early on visibility, and that's really where our big data and machine learning is able to give you that visibility, is early on in the life cycle, preventing the attack from progressing into something that then warrants further reporting or cause for concern. That's our second pillar covered off. The third pillar is how can we work towards mitigating attacks? Well, let's turn attackers into active penetration testers. By looking into remediations, I can see what have attackers been targeting, what are the actual endpoint paths, how they've been targeting that. And this is kind of content that can be put into ServiceNow or Jira and built in to my development team. Again, it gives development teams not only visibility into what's being targeted, but also visibility into how prevalent is that particular attack. What was the response code? What is the recommendation to prevent that kind of attack from occurring? And it also gives you that prioritization around this is something that is being actively targeted, rather than swamping your developers with tons of noise around potential issues. These are legitimate real world issues that should be targeted, that should ultimately be remediated as a point of priority. Additionally, on the attacker side, one of the things I forgot to mention is that when we are identifying an attack, it's not just something that you have to analyze on our platform. You can utilize our built-in take actions to push remediation activity through to your existing inline protection models like your WAF. So I can automatically do a shun of a user ID or device ID or, as I say, IP if you wanted to. And that can be on a manual basis or even down to an automatic shun against that device. We can also field repeat responses and alerts into your SIEM, your SOAR, and Slack and other webhook and syslog platforms. All right, appreciate that was a quick whistle stop tour, just wary of time, but hopefully you guys found this session really informative. As I said, happy to do a further deep dive. Please let us know and contact us, and we can go into a lot more features and granularity around our capabilities and our integrations that we support.
Thank you so much, Graham, for that very interesting demo today. Much appreciated. And we look forward to providing a more in-depth demo if any of you feel that API security is a priority to you today based on what you've seen. And I guess this is the moment where we just open it up for questions, and feel free to ask away.
So, Graham, I think we see a couple of questions coming in, a couple of great questions, by the way. Maybe you can take the first one, Graham, if that's okay for you, from Itas.
Yeah, happy to cover that one off. So one of the questions asked was, what are the supported platforms by the solution? Really great question. We've got deployments within AWS, Google, Azure on-premise environments. There are over 50 different connectors that we support, so we can connect into your API gateways, onto your network layer. We can connect into your existing load balancers. So it's a way that we're sitting out of band, but able to grab a a copy of that request and response, and then analyze that. But yeah, in terms of that particular question, if you let us know what is your requirement or what is your current architecture, happy to take that conversation further and say, look, this is where we would recommend connecting in. These are the kind of components. Things we do look into is, what is where is your environment located? What kind of encryption have you got? Where is it encrypted? And ultimately, we want to get to that point in it so we can go, well, this is where traffic's coming in, is being decrypted, and that would be the key point to analyze it. On many customer environments, we are also able to plug into multiple points, be it all the way down to containers, or be it on the API gateway. So as I said, over 50 different connectors and growing. So yeah, happy to kind of cater to any kind of specific needs that they have.
Great. And while we're on the technical side, Graham, I see another question coming in from Ray Sylvan. He's asking, how close to real time is the process?
Very good question. So we're ultimately analyzing those requests and response as they're being generated. We can do that via a hybrid approach, or you can utilize us as a complete SaaS-based model. Now that does mean that generation and alerting is being run on our Salt platform. One of the big questions we often get asked is, well, hang on, if you're not in line, how are you able to prevent the attacks? And the great way around is we're actually seeing APIs being targeted. You don't just have an attacker come in and immediately get success. It's around identifying that attacker really on in the life cycle. So picking up that anomalous, that suspicious behavior, and kind of the manipulation of the business logic around those APIs. And again, being able to curate and go, this is what we see as an attacker. And then you can choose whether you want to have a manual or automated blocking, by triggering that against your inline security in place. In terms of real time, I'd say it's near real time.
Great. Thank you, Graham. And I'll take the next one because I see a question coming in from Chris as well. Let me just read it out. It says, if API gateways and WAFs aren't effective to protect against most API attacks, does that mean these solutions are becoming obsolete? Yeah, so that is a great question, obviously. And, there's one thing that is really important to mention, and that is that API security is often positioned and presented as a product, which it isn't, right? API security is actually a security strategy, which has a technology stack of multiple solutions like the WAF and the API gateway, and technologies like Salt that integrate with each other to offer protection against these most advanced threats. So it's really good to understand that Salt actually does not replace the WAF or the API gateway. We don't compete with those solutions even. We really integrate to offer protection against those most advanced business logic-based attacks. Because if you look at the techniques that, for instance, a WAF uses, it's just not purposely built to detect and block these types of business logic attacks, right? It's using more rule sets, fingerprinting, deep packet inspection, those kind of techniques to determine if web traffic is safe. So it's actually very complementary from that perspective. And I have one more question, Graham, if it's okay for you, I'll take that one as well. This one is coming in from
Sure.
Amy. So let me read that out. She says, my colleague thinks attacking APIs is rare and difficult. How can I explain that hackers are doing this today? Yeah, great question, Amy. And this is actually a live example that I actually saw quite recently. Particularly if you go to the OWASP API top 10 list, the number one is the broken object level authorization attack, otherwise known as the BOLA attack. It's responsible for more than 40% of all the attacks that we're seeing on APIs. And the question is why? Why is it so popular? Well, it's the easiest attack to set up, but it's the most difficult one to detect and block because it's such a typical business logic-based attack. And what I mean with it's easy to set up is that this can be your next door, neighbor, boy or girl, 15 years old, that have Google Chrome in developer mode, going to one of the external facing APIs that they want to attack, and they have a YouTube tutorial next to it and within an hour, they're capable of launching these attacks. So these are no longer these sophisticated hacker groups behind this. Because it's so easy to launch, anybody nowadays can actually do it. And this is one of the reasons why we're seeing these attacks popping up more and more often. Because if you look at the breaches that are happening nowadays, you will see that many a time the anatomy of the breach shows that it was due to a leaky API. And one thing that I would definitely like to add, if you would like to read up on this, we have a separate department within SALT, which we call SALT Labs, which is a whole team of analysts that looks at external-facing APIs of big organizations and looks at the security posture of them. And we regularly release articles and blogs about our findings. And the most recent one is the one from Booking.com, a platform that many of us use to book trips, where through one of the APIs, hackers could just simply do a full account takeover and use the credentials of that person to also log into their Facebook account, for instance. Right? So very common platforms where you would assume that everything is in order from a security posture perspective, and still we were able to abuse one of those APIs. So definitely, great read. If you need some talking points about what those business logic type of attacks look like, we have many, many examples broken down on our website, on our blogs. So I hope that answers the question. Let's see what else we have in the question box. Maybe this one you can take, Graeme. I see that Doug is asking, how does ML and AI make it easier to detect API attacks?
Great question. The big thing around APIs is you don't just want to get one request coming in and trying to make a business decision or a security decision on that, because you're just not going to have context. APIs can go from a couple of requests to hundreds of thousands requests in a minute. What you need is you need to be able to analyze each and every single request and start building in that behavioral modeling. And that kind of data and telemetry is only achievable with big data and machine learning. And again, you don't just want to have a look at what is my data telling me today, but you want to have that big data drawn out over an extended period of time, like weeks, months, even up to a year. So this is what we can see over your entire environment. And that really helps us very quickly identify there's an anomaly. Does it warrant further inspection? Why are these parameters not matching? And again, allows us to very, very quickly, with a huge amount of data, accurately pinpoint this is a potential attack against that organization. I'm going to take this opportunity to even do a bit of a plug and say SALT Security actually has a patented machine learning approach to identifying attackers on SALT, within APIs. And I'm sure post the session we can share that patent and the link to that one. So awesome reading content, and yeah, we've got that down pegged, and great to see that that's running at the core of our technology.
Yeah, thanks, Graeme. This is an interesting question, by the way, because it has to do a little bit more with SALT and not so much with the actual technology. So Brett is actually asking, a lot of startup scale-up technologies are currently in some hard water due to financial issues and financial backing that is lacking due to the macroeconomic circumstances. So he's asking, can we tell a little bit more about the financials of SALT? That is a great question. That is the nail on the head. Yes, a lot of companies are dealing with the macroeconomics today, and you want to place a safe bet. So let me tell you maybe a little bit about who's behind SALT, right, from a venture capitalist perspective. So SALT is funded by one of the largest venture capitalists in this industry, which is called Sequoia Capital. Sequoia Capital, if you don't know them, they have, I think, almost 50% of all the NASDAQ-noted companies in their portfolio. And something truly amazing happened, I think, about 8 months ago when we became part of the Alphabet or Google family, where the investment firm under Alphabet, which is called Capital G, invested $144 million in SALT as well. So it doesn't only give us capital, but also a lot of validation if these types of companies start investing in these technologies. And another amazing thing happened 2.5 months ago And this is when one of the most renowned endpoint security vendors called CrowdStrike, everybody probably knows them, also decided to invest in Salt Security. This is actually an industry first. Never before did an endpoint security vendor invest in another security vendor, right? So this is pretty special. And what's also amazing is that we're now working closely together with the development teams of CrowdStrike to bring our solutions together and to offer a new proposition to our joint customers. And this is something that will be announced in due time, so definitely keep an eye on that. But that tells you that Salt Security doesn't only have the right validation in the market, but also has plenty of cash, if I may put it that way, for longevity and for a long partnership as well. So I hope that answers the question. If you meant anything else, feel free to drop it again in the chat box. Okay. So I think Graham, we can just wrap it up here. Let me just start by thanking everybody for taking time out of your busy day to join us for today's webcast. I just want to remind you that we have a ton of resources in the related resources title. Just click on it and it will point you to a couple of really nice reports, blogs, data sheets, white papers that you can read up on that will tell you a little bit more about, more extensively about what we spoke today. If you have an API security project on your radar, we would really love to have a chance to show you a more in-depth demo of the Salt Security solution, and you can actually see it in action. There will be a recording of this webinar, so we'll make it available on demand. That will happen sometime tomorrow. So if you want to, engage other people within your organization to have a look at this webcast, you can share the link and they can all have a look. So thank you again for being part of this session today during your busy day. We hope you have a great day, and hopefully we'll be in touch again soon. So thank you all. Bye-bye.
Thanks, everyone.